Hello students, welcome back to Organic Embers. Today I'm back with one more JE question. I would rate this question as easy to moderate. It's a great reminder for students that not every JE advanced problem is a hurdle. Some are quite straightforward and you definitely don't want to miss out on those marks. Now, what is the question here? There is a reactant 3-methyl-butane-2-one. It is treated with methenamine under heating conditions. It is forming product X, which upon reduction followed by hydrolysis, it is forming product Y. So what is the final product Y? Before we start writing the reactions, it's better to convert this UPAC nomenclature to the structure of the molecule. So for that, what you do is start from the root word and the suffix. It says "-one", that means it is a ketone and it is 2-butanone, and you see there is a methyl at the third carbon. So 1, 2, 3. So 3-methyl butanone. So this is a ketone when it is treated with methenamine or methylamine, right? What is the reaction happening? Remember, oxygen is an electronegative element. So because of this, the carbonyl carbon will become electron deficient, or you can call this as electropositive. Now, in methenamine, the nitrogen will have a lone pair of electrons. So that is electron rich. The electron rich will attack the electron deficient. So this is acting as a nucleophile and this is an electrophile. So the double bond is undergoing addition. Why so? The pi electrons which are loosely held between oxygen and carbon will go to the oxygen, right? So this is how you have to write the arrows, because arrows indicate the flow of electrons in organic chemistry. Now, since oxygen is taking away the electrons, the negative charge will be over here. Or oxygen is generally a divalent. But here in this case, it's monovalent, means it is going to be negatively charged. Now, what about this nitrogen? It is forming bond with the carbon. And what are the groups we have on the nitrogen? Methyl, hydrogen, and hydrogen. Is this the correct structure? No, actually it's partially correct, because on nitrogen there's going to be a positive charge. Why so? Because nitrogen generally it's a trivalent, but here it is a tetravalent. Therefore it's a positive charge, or it lost its electron to the carbon. Therefore it's going to be positively charged. Either way it is correct. Now, do you think the oxygen will remain like this? No, it's going to abstract the proton from here, because nitrogen also cannot have 4 bonds, right? So it will take away its electrons from the bond here, right? So it will take away the electron. What about the oxygen? Oxygen will take the proton. So that means hydrogen is going as proton. Remember that. Now, how do we write the next structure? Look at this. So don't forget about the methyl over here. Then there is a OH. And what about here? We have 1, 2, 3 bonds. There is a methyl and then there is a hydrogen, right? Like this. And nitrogen got back its lone pair of electron. Now, is this product X? Not really, because we have not considered the heat as of now into consideration, right? And also, whenever a carbon is attached to two electronegative elements like oxygen, nitrogen, they're not so stable. So what happens is they undergo dehydration. So what is dehydration? Removal of water. This hydrogen will go as H plus. What it does, it will give its bonding electron here, and the OH will go as OH minus. So that's nothing but removal of water. Then what do you get? Look at this. The nitrogen is attached to methyl like this. And this is called as imine. So from amine, right, when you remove the hydrogen and OH and you are forming a double bond, right? So such compounds are called as imines. How did I know this? Because see, they are giving lithium aluminum hydride. It's a reducing reagent. So somewhere I need to create a pi bond or a double bond. So where do I do that? Between carbon and nitrogen, because the dehydration can happen easily here. So this is our product X. Now, ultimately, lithium aluminium hydride followed by hydrolysis. It's going to reduce the double bond between carbon and nitrogen. So what happens? This is forming CH3, and here the hydrogen will add, here also the hydrogen will add like this. And where do we have this Y as a product, in which options? Check here, they have stopped at alcohol, so not possible. The double bond is still there. This is also not possible. But observe here, methyl methyl attached to carbon, methyl methyl attached to carbon, and then there is a secondary amine NHMe. Me is methyl, and it's still attached to methyl. So this is also correct, right? Therefore, the right option is option C. Students, this sequence of reaction is called as reductive amination. What is reductive amination? You are introducing an amine group and you're doing a reduction, right? So this is popularly known as reductive amination. These are quite common in organic chemistry, and it's also very important for your exam. Still have any questions on this? You can comment them in the comment section. Thank you for watching this video, and don't forget to like and subscribe the channel.